Okay, good morning, class. I am going to now do my second recording on concentration, which is what I promised a couple days ago that I would do, continue doing the worksheets after you have done the chapter questions that I have allocated you as homework. So we're going to look at how we are going to convert between units of concentration and look at the concept of dilution and working out the concentration of solutions when they are diluted. So hopefully you've gone through the chapter, and what I'm going to do is just show you how you can apply that knowledge when you are doing questions working between concentration units. So the very first question here is about probably not very appropriate, thinking it's a bottle of wine labeled 14% volume over volume, percentage volume over volume. This is important. This is what you get in liquids. When you have liquid solutions that are mixtures, their concentration with the key ingredient will be labeled as percentage volume over volume. So if you have 5 milliliters of this solution and you dilute it to 100 milliliters with water, what would be the concentration of the diluted solution with ethanol? So what we're going to do is use C1V1 is equal to C2V2. C1V1 is equal to C2V2, meaning concentration of the original solution and the volume that you take of it, and should be equal to the concentration of the new solution. Obviously the concentration will drop if you're diluting it, multiplied by the volume of the diluted solution. So here I'm going to use these numbers here. So I'm going to highlight those numbers, which is 5 ml of the original solution, which is at 14% volume over volume, and I'm going to dilute it to 100 milliliters. So I want to find out the concentration of the final solution. So what you're going to see here, note here, is that the unit of concentration, I can leave it to whatever has been given to me, and the volume I can also leave it in the unit that has been given to me. Just taking note that usually concentration is like molarity is per liter. Like you could choose to change it to that unit, per liter unit, but you don't have to, because you have two sides that'll have the same units. That'll be fine. So you don't have to change the unit. But if the question asks you to report it in a certain type of unit, then you have to consider changing the unit. So here we are. We're going to look at 5 milliliters of 14% multiplied by 5 milliliters should be equal to C2 multiplied by 100 milliliters. So can you see that the milliliter units are on both sides, which cancel each other? So it doesn't matter, just that your final concentration will end up in the volume over volume, the percentage volume over volume. So now C2, rearranging the equation, is equal to 14 multiplied by 5 divided by 100. So basically I've taken the 100, divided both sides by 100, and that's going to give me the concentration of the new solution, which is equal to 0.7% volume over volume. Important for us to write the unit as it appears in the starting solution, because we haven't changed any units. All right, moving on to the next question, which is what is the molarity? So now we're talking about moles per liter. Yeah, what is the molarity of a solution which is 47% So you have 40 grams of sucrose in 300 milliliters of water. So if I want molarity, I want actually moles per liter. So what I'm going to do is, firstly, I'm going to convert number of moles of the sucrose is 40 divided by the molar mass of sucrose, which is 12 times 12 plus 22 hydrogens, which is 22 times 1 plus 11 times 16. That's the molar mass of sucrose. What I might do is clear this end over here so I can have some more room on the outside. This is a very squishy, tiny box for me to do my calculations. So basically I've got 0.117 mole of sucrose in 300 milliliters. And what's concentration? Concentration is equal to number of moles over volume. The volume needs to be in liters here because its molarity is moles per liter. So what I'm going to do is convert that 300 milliliters into liters and have 0.117 mole in 300 multiplied by 10 raised to minus 3. That makes it into liters, and my answer is going to be 0.390, and the unit is capital M, which is molar. All right, moving on to the next equation or the next question. What is the volume? What volume of water must be added to 1 liter of a solution containing 70.2 grams of NaCl to produce a solution of 0.67 molar? So I'm going to have to convert the NaCl into moles, which is N is equal to 70.2 divided by molar mass of salt is 58.5, and that's in 1 liter already, so it's basically 1.2 moles in 1 liter, which is 1.2 molar. Now I know C1 and I know V1. Yeah, I've got 1 liter. So I'm going to say C1 is 1.2. V1 is 1 liter. I want to find out C2. C2, I've been asked to prepare a solution of 0.67. I need to find V2. So we just need to substitute in here and find the value of V2, which I think you should get to. Let me just calculate this. So your answer should be, the final volume would be 1.79. So you already have 1 liter in there, so you're going to add 0.79 liter, which is 790 milliliters. You would be adding to it to bring it to this molarity. All right. Here, the next question we are going to do is now in a different unit. You have 5% mass over volume. So 5% mass over volume of cloudy ammonia is needed to make 250 mils of 1.5% mass over volume. So again, this is straightforward. You have C1 is equal to 5% mass over volume. C2 is 1.5% mass over volume. Your volume of the initial solution you need to find. You want to see how much you should take, whilst the final volume that you need is 250. You want to make a 250 ml solution. So you're going to go ahead and find the volume that you need to take of the original solution, again using C1V1 is equal to C2V2. And then the second part is asking you to calculate the mass of ammonia present in 150 mils of the solution, the 1.5% solution. So I'm going to quickly work out over here the part A, which is V1 is equal to 1.5 multiplied by 250 divided by 5%. So we're going to get a volume of 75 mil. You have 75 mil of the solution that you need to take, the 5% solution, and dilute it to 250. Now, part B, you have a 1.5% solution mass over volume, which is equivalent to 1.5 grams in 100 milliliters. Yeah, that's your 1.5%. So if you want 150 mils of that solution, how many grams of the ammonia should you have in there? You would go with, let's say, 1.5 grams in 100 mil. So how many grams in 150 mil? So you could just go cross multiply and equate and find out the x. X is equal to 1.5 multiplied by 150 divided by 100, which gives you a mass of 2.25 grams. Right? So basically, laying out your calculations like this always helps to work out the unknown, and cross multiply and equate to find out the unknown. Okay, moving on to the next question, which is question number 5. Now what you are doing here is you have lead nitrate is added to 60 ml of distilled water in a beaker and stirred to dissolve. So you've taken certain mass and dissolved it in water, in 60 ml of water. Now 10 ml of this solution is then transferred to another beaker and mixed with 20 milliliters of water. What are the concentrations in molarity of these two solutions? So the first solution we will go with is find out the number of moles of Pb. 3.5 divided by molar mass of PbNO3 is 331. You can calculate this yourself by using the molar masses of lead, nitrogen, and oxygen in correct proportion, and that will give you the molar mass of lead nitrate, and you're going to calculate that as 0.0106 moles. Now you are adding this in 60 mils, so the concentration is 0.0106 divided by 60 into, you want it in molarity, so you're going to actually convert that into liters, minus 3. which is equal to 0.18 molar. So that's your concentration of the original solution. Now you are diluting that solution. You're taking 10 milliliters. So C1 is 0.18 molar. Volume that you have taken is 10 milliliters. And C2 you don't know. You're going to find out. And V2 is 20 milliliters. You're making the volume and mixed with 20 milliliters of volume. So you're actually adding 20 milliliters to it. So the final volume is 30 milliliters realistically, not 20, because you're adding. So you have to read the question carefully. Here it says you are adding it to 20 ml. So your final volume is not 20 ml, but it's 30 because you've got 10 milliliters of the original solution. It's going to make that to a 30. So then your C2 is equal to 0.18 molar multiplied by 10 into 10 raised to minus 3. Remember, we have to convert that into liters. Or we could actually leave that all in milliliters, because both of those values will need to be multiplied by 10 raised to minus 3, which means being on the opposite sides of the equation, they'll cancel out. So I could just leave it as 10 milliliters and divide it. If you want to, if you feel comfortable, convert it into liters and use it, then you are following the process correctly. And here you would just say 30. And this will give us 0.059 molar solution. So I hope this has kind of given you an idea of how you need to tackle questions like this. I'm going to move on to the next bit of the questions, but just going to give you a guidance on what you need to do so you can carry on the calculations yourself, and I'll give you the correct answer, write the correct answer for you so you can actually work through the questions yourself. Just explaining this question now, question number 6. So you are looking at, I'm going to highlight the things, 30 milliliters of sodium carbonate solution is mixed with 270 mils of water. So be careful here. The 270 mils is now being added to the 30 mils. So your final volume is 300. The resultant solution has a sodium carbonate concentration of 108 molar. What is the mass of the sodium? So now we need to go back to the mass. So there's a bit of calculation over here that we need to do. Firstly, we're going to use C1, V1 is equal to C2, V2, where C1 we don't know, V1 is 30, C2 is 300, remember the 270 plus the 30, and that's the concentration is given to us as 0.108 molar, and V2 is equal to 300 milliliters. Now you use this to calculate the concentration of the original solution, which is you should get concentration of C1. The original solution is should be down to 1.08 molar. That's what you should get. Just rearrange the formula, calculate your C1. Just fix that a bit. and then your final answer, the mass that you are going to calculate of the mass of sodium carbonate, Na2CO3, will be the number of moles that you get in that solution. You'll find out the moles, and you would multiply that with the molar mass. So how do you find out the moles from the concentration? Over here, you will use the formula N is equal to C times V. So now you know the concentration, how much volume is there in that solution. It's actually 300 milliliters, remember? So find out the moles and then bring it back to this one. Bring it back into here and calculate the mass. So I'll leave you to work that out. Your answer should be 3.4 grams. So see if you get there. Let me know if you get stuck with that. I'm just giving you guidance on how to proceed with these type of questions. Okay, so the next one is, what volume of water must be added to 180 mils of 2.389 molar sodium hydroxide to produce a solution of given concentration? So quickly highlighting the numbers that I need to work with and what they are. So my volume C1 is equal to 2.389 molar. Volume is 180 milliliters. C2 is 0.765 molar. That's what I want, and I want to know what the volume is going to be. Yeah, and don't forget here, once you find the volume, find V2 and then subtract it from the 180, because you're adding. They're asking you, the question's asking you how much would you add. So whatever answer you get, find V2 and then subtract 180 milliliters from it. All right. The answer that you should get here is let me just work that out. Should be around 382 milliliters. All right. Question number 8. How will you proceed? Again, you've been given a glucose solution in percent mass over volume, and this is what you are mixing it with. You're mixing two solutions that have different concentrations. So you're taking 50 ml of glucose solution at 2%, mixing it with 50 ml of 6% glucose solution, and 200 ml of distilled water is then added after that. So can you see there's a few layers here? So what is the concentration of the final solution? So basically you are going to firstly you're going to add up your total number of the mass that you have in the solution. So you're going to look at 50 mils of 0.2%, so 2% to concentration multiplied by volume will give you the mass. So the mass of the total amount of glucose, 2% multiplied by the volume, which is 0.5. So 0.05. just going to write that properly here. So the mass of the glucose that we have is in 50 ml. In 50 milliliters, we have 2 grams multiplied by 50 mils, which is 1, 2, in percentage. So it's basically half of, because it's percentage, meaning out of 100. So in 50 mils, you would have half the quantity, which is 0.1 gram. And in that other solution, in the 50 ml 6% solution, you have 0.3 grams. I'm doing something wrong here. Sorry. Let me just start again. Here we are. So in 100 milliliters, I have 2 grams. So in 50, I should have done this before. In 50 milliliters, I have 1 gram. In the other solution, the 6% solution, in 100 milliliters, I have 6 grams. So in 50 milliliters, I would have 3 grams. So in total, I have 4 grams of sugar in 100 milliliters. Yeah, because there's 50 milliliters of each, so that's my mixture. Now I'm adding 200 mils of water to this. So my C1 is 4% mass over volume, and my volume is 100 milliliter, and C2 I'm going to find out, and V2 is I added 200 milliliters, so in total I'll have 300 milliliters. So you will work out your C2 based on this, which should be equal to 4 in 300 would be 1.3% mass over volume. That should be our final answer. That's what we should get. So work your calculations out and see that you get the same answer as I am. Okay, moving on to the next one. 50 mils of 16% silver nitrate solution is added to an equal volume of distilled water. So what is the concentration of the diluted solution in parts per million now? So what we want to do is we're going to have to convert some things. We have grams in 100 milliliters. So let me just write that down. So in 100 milliliters, I have 16 grams of silver nitrate AgNO3. So I have 50 milliliters, which is 8 grams. Now, if I add another 50 mils of water to it, so I would have C1 is equal to 16%, and volume is equal to 50 mil. V1 is 50 mil. C2 is, we need to work it out, and then V2 is 100 mil, because this is now added to another 50 mils. So basically I could have worked that out from here, which is 8 grams in 100 mil. That a little bit bigger. This is 8 grams in 100 mil. Now for ppm is milligrams per liter. So I want to convert that into milligrams first, which is so if I have, I need to convert that into 1 liter. I want to find out the concentration in 1 liter, not in percentage. So that's basically going to be 80 grams in a liter. I'm going to convert that into milligrams, which is 80 multiplied by 10 raised to 3 milligrams per liter, which is equal to 80,000 milligrams per liter, which is 80,000 ppm. Or you can write it as 8 into 10 raised to 4 ppm. So hopefully that kind of conversion is something that you will work on from the textbook questions as well as from what's given over here. Yeah. And remembering that parts per billion, which is in the next question, is also equal to micrograms. So micrograms is even 1,000 times smaller than milligrams. So you would actually need to multiply. If you're in grams, then you would multiply by 10 raised to 6. So work out these units properly. From the data booklet gives you a list of conversions, but you would also be able to do it from the textbook. The textbook will show you that as well, converting micrograms to grams or grams to micrograms and vice versa. So your question number 10, your answer should be, it's very similar to the conversion from, this is in ppm. So you're going to work with ppm, 600 ppm. You want to convert that into micrograms. So in micrograms, you would just multiply by 10 raised to 3 micrograms is equal to 1 milligram. Converting that into micrograms would give you an answer of 600 multiplied by 10 raised to 3 micrograms per liter, which is 6 into 10 raised to 5 parts per billion. So seawater contains, this question is interesting, seawater contains these many moles of potassium ions. What is the concentration in parts per billion? We're going to have to convert that mole into grams of potassium. So you're going to have to go, mass of K plus ion should be equal to moles, which is 0.0097 multiplied by the molar mass of potassium, which is 39.1. And then work out the grams. This will be in grams, and work that out into micrograms. And your answer should be, just do this, 3.8 into 10 raised to 5 parts per billion, which will be micrograms per liter. Now, the last one. A solution of insecticide is made by adding 30 grams of compound Z to 2 liters of water. So you're taking, not 30, sorry, 3 grams. Oh, misreading, too early in the morning for me. 3 grams of insecticide in 2 liters of water.